Hello student and welcome to today's online session. Myself Dr. Sandip Patil, Assistant Professor in Chemistry at the Maratha Vidyaprasarak Samajas, Srimati Vimlaben Khimji Tejokaya, Arts, Science and Commerce College, Deolali Camp. Today we continue our discussion on the topic errors in quantitative analysis. This topic is introduced in the course Physical and Analytical Chemistry for the SYBSc student in the semester 3rd. We know that the course Physical and Analytical Chemistry having two sections. First section is for the physical chemistry and the second section for the analytical chemistry. And our topic errors in quantitative analysis is included in the second section, that is in the analytical chemistry. Before started today's session, we take quick recap of our previous session. In the previous session, we had discussed some introductory part about the errors during the analysis. We had also discussed two important terms about the error, that is the accuracy and precision. In that, we had also discussed about the methods of expressing accuracy. We know that generally the accuracy is expressed in terms of absolute error and relative error. Along with, we had also discussed the method of expressing precision. In that, we know that the precision is generally expressed in terms of the deviation, average deviation, then the standard deviation and the relative standard deviation. In all these points we had discussed in our previous session along with some numerical problems related with the method of expressing accuracy and precision. Now in the today's session we discuss about the classification of errors. Therefore, the learning objectives of today's sessions are to study the classification of errors and to discuss the different terms to errors in quantitative analysis. Therefore, the errors are generally classified into the two types. First type is the determinate errors and second type is indeterminate errors. The determinate errors are further subdivided or subclass into the four types. First is the operational error, second one is the instrumental and reagent error, third one is the error of method, and fourth type is the additive and proportional errors. In the today's session, we have discussed all these types of errors one by one with examples. Now, first type is the determinant error. Generally, the determinant error is called as the systematic errors. The determinant errors which have some assignable causes, the errors can be discovered, corrected and hence can be eliminated. The determinant errors are subdivided on the basis of their sources. For example, the errors in the experiments, the errors in the equipments used for the analysis or the person carrying out the experiment. Determinant errors are subdivided into the first class, operational and personal errors. The operational and personal errors, the individual worker held responsible for such errors. Therefore, it not connected with the methods or procedure used for the analysis. The operational and personal errors are generally physical in nature and occurs when the sound analytical technique is not followed. There are some examples of operational and personal errors. First example is the mechanical loss of material in various steps of analysis. Second example of operational and personal error is underwashing or overwashing of precipitates. Another example of the operational and personal error is the ignition of precipitate at incorrect temperature. The more example of the operational and personal error is insufficient cooling of crucible before weighing. One more example of operational and personal error is allowing the hygroscopic material to absorb moisture before or during weighing. All these are some examples of operational and personal errors during the gravimetric analysis. We know that the personal error arises from the constitutional inability of an individual to make a certain observation accurately. For example, this includes the misreading of a burette. During the volumetric analysis, many students confuse how to take the burette reading. Some student can measure or note down the upper meniscus, or some student can be note down the lower meniscus. Okay, this is the misreading of burette. Another example of such an error is a listing weight incorrectly. Sometimes the listing 2 gram weights when a 1 gram weight was used. We know that the inability to understand the endpoint correctly. Some student having confusion to recognize the color of endpoint. Okay, the orange color being understood as a pink color. This is operational and personal error. Another example of such error is the misinterpreting directions. Then another example is a mistakes in calculation. We know that calculation is most important during the analysis or during the different type of operational analysis. How to minimize the operational and personal error? Okay, for the minimization of such a type of errors, or for the elimination of such a type of error, we can eliminate the error by the repeated measurement. We can repeat the same experiment under identical conditions to minimize operational and personal error. Another way to minimize the operational and personal error is to develop a skill and self-discipline during the analysis. These are some important points for the minimization of operational and personal error. Next type of determinant error is the instrumental and reagent error. Such a type of errors arises due to deficiencies in quality of measuring devices. Then it may be arises due to reagent used for the experiment. We know that for the analysis, very high quality or high purity reagents, solvents are required. And if there is no purity or there is any impurity in such a reagents or in a solvent used for the analysis, the reagent error may be arises. Then some examples of instrumental and reagent errors. We know that before the measurement of pH, we have to adjust or we have to calibrate the pH meter. When the 0 point of pH meter may be wrong, then there may be a instrumental errors in the analysis. Another example of the instrumental error is the burette may not be calibrated properly before the volumetric analysis. Another example of such a type of instrumental error is the balance is not functioning properly. They cannot give the proper weighing before the analysis of sample. Another example of reagent error is a reagent contain a reactive impurity, and as concerned with the solvent having a impurity, such a type, so at that type the reagent error may be arises. These are some examples of instrumental and reagent errors. Then how to eliminate these instrumental and reagent error? First way, by fixing the instrument. Then we can eliminate these instrumental errors by calibrating the meters and the glassware before starting the experiment or before starting the analysis. Another way to reduce the instrumental and reagent errors by using high purity reagent such as other means. Then when the source cannot be located or cannot be eliminated, an appropriate correction factor is applied to minimize or to eliminate the instrumental and reagent errors. Next type of determinant error is the errors of method. This type of error is a chemical or physico-chemical in nature. This type of error lies in the property of the system being studied. Therefore, the errors originated from incorrect sampling and from incompleteness of reaction. There are some examples of errors of method. When we consider about the gravimetric analysis, such a type of errors may be arises due to the decomposition or volatilization of compounds on ignition. Then second thing is due to the precipitation of substances other than the required one, and there may be due to the solubility of precipitation, co-precipitation and post-precipitation phenomenon during the gravimetric analysis. These are some well-known examples of errors of method. When we consider about the volumetric analysis, the errors may be arises due to failure of reactions to proceeds to completion. Then it may be occurs due to the side reactions. Then such a type of errors may be occurs when the reaction of substances other than the constituent being determined, and the error of method may be arises due to the difference between the observed endpoint and the stoichiometric end of reactions. These are some well-known examples of the errors of method in the gravimetric analysis and the volumetric analysis. Then how to minimize errors of method? We know that the errors of this type which are inherent in methods are difficult to detect, difficult to minimize or remove. Okay, and they can be corrected by change the condition of the experiment or by using running the blank samples, and also we can minimize the error of method by applying the appropriate correction factors. These are some points. By using such a point we can minimize the errors during the analysis. The last type of determinant error is the additive and proportional errors. The additive errors are called as the constant errors. Okay, and the absolute value independent of the amount of constituent in the sample. This means that for a different weight of the sample, the absolute value of error remains the same. Then the proportional error. The proportional error increases or decreases in proportion to the additive error. Will magnitude of additive error amount of the constituent in the sample. That means for the different weight of the samples, the absolute value of these error are different. We discuss some examples of additive errors. Okay. When the amount of reagent required to bring about the color change in a volumetric analysis, that means this volume usually small remains the same regardless of the total volume of reagent used in the titration. Again, the relative error from the source increases as the volume required for the titration becomes smaller. Then how to minimize the additive error? For the minimization of effect of such additive error is used as a large amount of sample as a consistent with the method to be used. We have to use a large amount of sample during the analysis. This is the way to minimize the additive error. Then some examples of proportional error. We know that the effect of interfering contaminants in the sample, if not eliminated, somehow causes a proportional error. Okay, an example of that proportional error is a common method for the analysis of copper involving reaction of copper second with a iodine. The quantity of iodine produced in the reaction is then measured. Iron second is present, will also react with iodine, that liberating iodine as well. Unless measures are taken to prevent this interference, the iodine produced will be measure of the sum of the copper and iron in the sample, and the analysis will give unnecessary high results of the percentage of copper. This is an example of proportional error. Then how to minimize the proportional error? In that, the magnitude of this error will be fixed by the fraction of iron contamination and will produce the same relative effect regardless of the sample size. This is a way to minimize the proportional error during the analysis. The second type of the error is the indeterminate errors. The indeterminate errors are called as the random errors or accidental errors. And such a type of errors are caused by unknown or uncontrollable factors. They are shown by small differences in the successive measurements made by the same person under virtual identical conditions. And these errors cannot be predicted or cannot be determined. Such type of errors can be personal, it may be instrumental or due to variation in externals. The indeterminate errors can be treated by the statistical methods, okay, and it is only indeterminate of errors which statistical treatment is valid. The distribution of indeterminate error is expected to follow the normal distribution law, and the law stated that, or according to this law, if sufficient number of observations are taken during the analysis, it can be shows that first point, it can show small errors occur more frequently than large ones. Second point, from the reading we can say that large errors occurs relatively frequently. And the third and important point, on the basis of observation, positive and negative errors of the same numerical magnitude are equally likely to occur. Then next important point is some examples of the indeterminate errors. In that, first example for the indeterminate errors is the equilibrium position of a balance varies slightly for every successive weighing. Second example for the indeterminate error is the needle of pH meter or a spectrophotometer moves slightly and gives every time a different reading. Then another example of indeterminate error is a person reads the meniscus on burette a bit differently each and every time. As earlier said, there is a confusion how to take a burette reading, as a upper meniscus or as a consider as a lower meniscus. Another example of indeterminate error is a liquid drawn through the chromatographic column packing slightly differently each time gives the different RF value. These are some examples of indeterminate errors. Finally, in the summary, in the today's session, we have discussed about the classification of error. The errors are classified into two groups. First one is the determinate error, second one is the indeterminate error. Further, the determinate errors are further classified into four subclasses. First one is the operational and personal error, second one is the instrumental and reagent error, third one is the error of method, and fourth subtype is the additive and proportional error. All these points we had covered it in our today's session. This is the session assignment for students. In that, you have to solve first question, how will you classify error, with examples. In that, we have to solve a second question, what are the causes of operational and personal error, instrumental and reagent error, and the errors of methods. Dear student, you have to solve all these assignment on a blank paper and send me on a Google Classroom created for the FYBSc student. Now, in the next session, we will discuss on the minimization of errors, how to minimize errors during the analysis, and also we will discuss significant figures and the computations. Thank you, students.